Hello and welcome to another edition of AC with Wacey. I'm coming to you from a job site today. Gonna show you some of the indoor air quality upgrades that we feature on some of our new construction. This one's still in progress. Not everything's done, but you'll get a decent idea. So as you can see here, there's a duct hanging out in the attic open. And we get questions all the time about why we're doing that. As you can see here, it goes into a dehumidifier, which is pulling in air on this side and filtering it as it pulls it in, and then it's feeding the air out that duct into the other side of the attic. Basically the point of that is to pull this end here of the attic into a negative pressure and put a positive pressure down there, circulate the air in your attic, and make sure that humidity does not build up. This home is going to have can't remember, like 6 inches of spray foam in it, so humidity in the attic will build up between the sheetrock and the spray foam if you don't dehumidify it. If you have a spray foam home and you do not have a dehumidifier in the attic, I encourage you to buy a cheap thermostat, humidistat from Walmart. You can buy them for like 20 bucks and put it in your attic and check the humidity level. If you're getting over 60%, you'll see it in June, July, that time of the year. If you're getting over 60%, you're getting problems with your building materials inside. Wood and stuff like that will have problems, as well as giving the propensity to have mold and stuff like that growing. As you can see, the dehumidifier just plugs into a 110 outlet, has a drain out of it. Our plumber will be bringing us a drain over to tap into. And then on this side of the hanger, we have a fresh air unit. You can see we have one line that goes outside and is pushing air out. I guess this kind of shows you the airflow. But anyways, one line pushing air out, one line pulling air in. It's set for a specific CFM setting. On the inside of your unit, you have a filtering mechanism that is basically catching everything that air is pulling in or putting out, and it's filtering the air as well as it's filtering the air as well as sort of conditioning it and mixing the inside and outside air to where you get some of the energy recovery back. But anyways, that's basically our fresh air machine. And the other two sides of that come out. One goes to the supply and one goes to the return. Basically puts fresh air out into your supply so that it blows throughout all of your rooms, and then pulls from the return to get dirty air out of your house. Over here we have this is a Samsung air handler. It's a ducted unit like any of your traditional brands, basically. We have our hung right hangers with a secondary drain pan on the bottom. Again, we'll have our heat kits for supplemental heat. You'll notice it's a smaller heat kit than a lot of units, but and then safety switches for both the primary and the secondary drains. And then on the end here we have a Honeywell electronic air cleaner. So basically, get this door off. You have an electronic air cleaning setup. Is basically going to have your pre-filter here, which you clean out once about every 30 days or so. The other side is another electrostatic filter that'll catch stuff on the other side. And in between you have your particles being charged through this center system. You'll notice on the Train Clean Effects or American Standard AccuClean, this is more of a honeycomb look, but this is just a little different setup. It's basically charging it on one side and catching it going out the other. Catches a lot more allergens and mold and virus and bacteria and all of that good stuff. It's not a terribly costly addition, but it's definitely takes a little bit. I believe these were about $900 to add on to each system. We have 3 systems on this home. They're smaller systems. I believe we have 2 3-tons and then 1 ton in the mother-in-law suite. But I would rather zone it with smaller systems and put 1 5-ton covering a large majority of the house, and then cut the other one to a small size. It's basically gives us a way of zoning without having dampers and stuff. You'll notice all of our ducts on both ends have duct sealant on them and mastic. We're going to hit this system with a duct blaster before we start it up, which will essentially the duct blaster will give us an idea of how much leakage there is, as well as how much air is going to come through that particular duct. And basically we have a number set by energy code that we're aiming for as far as on the leakage. And then we have our design that we did through RightSoft with our manual JDNS that tells us how much CFM we're wanting per room. You'll notice we have a bigger one here, is a return back from the master bedroom area, gets the bedroom bathroom. There's another one over there in that bedroom hallway area. And then we have a large return over behind the unit coming into it. On all of my returns, I try to do a metal box with insulation liner. You can frame them in with wood and do some insulation that way, but it's more prone to leakage than using a metal box or boot for the returns. And I want that air as clean as possible as it's pulling back, and I don't want to be pulling in from the attic or anything like that. Typically on a lot of them we use this wider strap than what you see in a lot of homes, just because it does a better job supporting, and you don't need metal brackets down under them that can cause cutting and stuff later. You'll notice I split the master bedroom that's down below us here into 2 grills. This could have been accomplished with 1 large grill, but what I was worried about there was with 1 large grill, it would be running really borderline on the air it needs, whereas when we do 2 like that, we can use our dampers and get it to where we want. Basically, when we design these, we have an idea of how much air we want in every room, but our door over there may or may not get it sealed as tight as some other houses, or the insulation may not be as tight, or it might be tilted slightly from north to south from where we had it in our design. All of those things change the heat that a room will absorb, which changes how much cooling it needs. So having a little bit of overkill and being able to damper it back afterwards if there's a problem is better. I know there's going to be somebody from another part of the country or even from around here that's going to comment on this and say you shouldn't do flex duct, you should have metal duct, and metal duct is a better ducting. However, budget comes into play at some point, and most of the houses that we do here in this area of Texas are going to be flex duct. It's not just us, it's basically everyone in the area, and because we're competing on pricing, we kind of bid the same. We of course give options for all of that stuff, but 95% of the jobs are going to be a flex duct. Occasionally we'll do a ductboard trunk line and then come off with them, but most of it's going to be flex duct. The next little option that we have on this house that I'm a real big fan of, and I've only recently started doing. You can pick these up at Home Depot, but they take a minute to install. But anyways, we're doing these. They're about $200 a piece. But what they are is they're a very quiet bath fan that activates based on motion and humidity. So rather than having a light switch by the door here that you would flip up, when you walk into the room, that bath fan senses the motion and it kicks on at a low speed. So while you're in the room, it's running. When you walk out, it gives a timer of about 5 minutes, or you can set the timer for longer. And once you go by the 5 minutes, it shuts it off. And if you take a shower or something and that humidity is still sitting in the air, it's going to activate on that timer to make it run longer and get that humidity out. I really like it in spray foam homes as we're constantly battling humidity, and if you can approach it at the source and take out human error of not turning on the bathroom fan, it's a great little addition. They're a lot more expensive than normal bath fans, but that's kind of part of it. Out here in the living area, we have a spiral going along. So basically they wanted to cool this area and have a vented ceiling with no room for ductwork or anything. So we're doing the spiral to feed this room. We'll have returns in each of the hallways. And then we have another Samsung unit with the same filter system and everything up there. We'll be feeding some fresh air over here in the corner just because they have a fireplace going in here. And we want to make sure that even if the systems are off and it's not circulating that fresh air, if they're burning their fireplace, we're adding a little more fresh air into this big living area. And then I honestly don't know if my guys got that far. They did. Okay. So over here in the mother-in-law suite, and again, excuse the mess, it's still under construction, but we have what we refer to as pancake units. But what it is a small ducted unit. This one is a high static unit, which means it gets a little more pressure out the duct than a low static unit. I have this one on a hanger. You can see where you can bolt them up. And this one, they've just started the process of putting it together, so it's still, the ductwork can still look a little off. But this is basically the unit. It's about 26 inches wide. I believe it's 34 or 5 long. And you have Freon lines with flare connections, sort of like a ductless unit. And then it comes with the built-in condensate pump as well as a gravity drain. You can use either one. We'll probably pipe both of these out. That way if our gravity drain blocks up, it's still got the pump on it to pump out. And then if they both fail, we got a safety pan underneath of it, which will have a safety switch on it as well. And basically get all our drains out there. This will have its own outdoor unit. You can do these with multiple indoor units, but this one will be just be a one-to-one mini split system. The filter on it will be in the ceiling down here. They don't get the box in yet, but it'll just be your standard pleated filter. It's a small enough area. Doing an electronic filter for it was going to be difficult. We have quite a bit of ductwork on this one. You'll notice we have 9 feeding 2 6s, and then 2 6s on the other room as well, and the 5 in the bathroom. All of those, if you're used to running ductwork, seem like overkill for the particular room. But because these mini ducted systems run a little different static pressure, it's better to have more duct to relieve some of that and let it run at a lower static. And basically we have a friction rate that we use when we're designing our ductwork. Your friction rate will have everything from the length of your duct to the number of turns in it to the type of duct, being flex, metal, etc. And then the rooms and what you're doing. And that friction rate, you have to use a different one for this than you would use for, say, a normal ducted unit like we have over there. And then again, here we have the bathroom fans. These bathroom fans have a bigger, sorry, I'm going to grab a couple screws while I'm here. But anyways, they have a bigger outgoing vent than a lot of bathroom fans. That bigger outgoing vent will essentially quiet the air down. They run a little under a zone, whereas a lot of bathroom vents will run 3 to 5 zones, which is extremely quiet. The other thing that it does is allow it to kick more air out quicker if the humidity gets high. This is actually the outgoing vent for our fresh air. And then back here we have our dryer vent, and then you'll notice the incoming air for our fresh air has just an opening with the screen. There's no damper, and then a bathroom vent outgoing there. And essentially we try our best to seal all of them, obviously, as we put them in. And then on this one, it's a little bit different because you'll notice they have sheathing on the walls, but no sheathing on the roof, which is a little odd. But had they sheathed all the way up to the roof to where our connections were going out, we would actually take spray foam and foam around on the inside, even though we already have the outside sealed as well. Just because when you're building, you want as tight of a building as you can to have a more efficient building. And basically, the more of those cracks and crevices on your penetrations that you can seal before the foam, the actual insulation foam comes in, the better off you are. So you're sure that it's taken care of and the foam for the insulation doesn't have to work its way there. So make sure that you're always doing your penetrations and everything first. All right, that turned into a little longer video than I anticipated, but hopefully it kind of gives you an idea of what we're doing and how, why, all of that good stuff. And if you have any questions, I guess give us a call, shoot us an email, all of that good stuff. And until then, I guess I'll talk to you next time.